And we are now the third year here, and it's a great place to be, great organization every year, because a lot of the discussions we have here, they are more or less about what you do with the data you capture, how you analyze the data, how good you can analyze the data, how the processes are here given, how you can get those data. Especially not talking about 3D, because 3D is kind of easy. You use some still cameras, you take a shot, and you have your model. But what is happening if you talk about really 4D capturing? And that's about us. We are Emergent Vision, Canadian-based company. So to give you an idea what we did already a long time ago, this is one of the largest volumetric capturing studios, I believe, still in the world. It was at that time, 2018, so which is already now 7 years ago. It was more than 1,000 square meters size. It was done with more than 200 cameras from us. They had 8K resolution at that time. We always provided and supported to get this setup running, stable. What means volumetric capturing, 4D capturing? Typical applications are about digital humans with avatars. Of course, here we don't talk about the typical still avatar, which is then AI-based, more or less getting some movements later. We talk about real reconstruction of people moving in the studios. Typical customers from us working also in the training and simulation field, not only industrial, but also, for example, firefighters and so on. Live performance and live events are getting more and more. There you see also more and more live events happening in Fortnite engines, but also in other engines or with your goggles at home. And of course, fashion and retail. Even those people, they are looking more and more into the 4D world, because it's good to see that something is fitting, but it's even better to see something moving on the body. Big difference between 3D and 4D is, no surprise, time. So we bring in more or less really the movement of a body, of an object, whatever you want to see. Instead of you talking about 3D to 4D, one of the biggest must-haves is the synchronization between the cameras, data throughput, so you can trust that all data from the cameras really ends up in your SSDs, for example. For that, you need a storage system which can handle the amount of data which are coming in quite fast, and processing. And it takes a long time, but let's say, for example, with our approach, if you have the budget, you can insert more GPUs, for example, to do the reconstruction part, and then everything speeds up. So we talk about, in our case, for example, as I said, on high-speed gigabit Ethernet cameras, so they are using the Ethernet standard. That the standard gives you the possibility to have high frame rates and high resolution combined into one camera. Those systems are completable, scalable, so you can decide from your side if you want to start with 20 cameras, if you want to start with 50 cameras. You can, as I said already, you can expand the system after 2 years, go to 100, 200 cameras and so on, and go from there. The only limitation you more or less have is that you have to invest a little bit more money in the beginning, because you more or less you have to get the infrastructure up and running, which means you have to have the cameras, the switches, the workstation in the background to do all the process in one place. As I said, we have over 300 cameras in the meantime, different sensors. So let's say from a small, let's name it small for this type of application, 12 megapixel sensor, which can do already more than 60 frames per second, up to a type of de facto standard, which is a 25 megapixel sensor, which is used in a lot of studios in the meantime, up to the latest model, which is popping up end of this year. It's a 105 megapixel sensor, which can still do more than 100 frames per second. Coming more or less of the infrastructure behind that. As I said, we are Ethernet based, so as also here, you can use standard switches in the market and from there you normally record on fast industrial SSDs, or if you like, you can use GPUs, a lot of GPUs with GPU Direct for compression and send the data, for example, into the cloud, or for compression and record, or for really even real-time analyzing. Where with, let's say, technologies like from us, you can easily then expand using different cameras models and use still the same system behind.